Hi folks, and welcome back to Physics with Captain Rod. I'm making this video to be kind of an introductory video of the concept of velocity. And the first thing I'd like to talk about is this right here, this coordinate system and why it's there. So, imagine your buddy calls you, whoever that is, and asks you for directions to Pizza Hut. Probably the first question you're going to ask them is, well, where are you? Then you might give them a series of directions that might look like, drive so many miles east and then so many miles south, or maybe 20 blocks north and 15 blocks south, or something like that. So, in order to give them directions, though, you have to have some sort of agreed set of directions, if you will, that everybody is working with, right? That's what this is. So this is a coordinate system that's put in the problem that I'm going to use to discuss the motion of these two cars here and here. I like to call that, tracking particles. So in green, we can use the x coordinate here to describe the location of that green car. And then we could use this distance here in red, like from here to here, to describe the x coordinate of the red car. I'm going to leave the red car off for now. We're going to bring that in later. Right now, we're just going to talk about this car right here. So imagine that this car is moving along, covering 2 meters each second. And that's what we would call the speed of the car. And imagine that it starts 10 meters away from the origin. So meaning that this distance to, I'll just say basically the center of the car is 10 meters. And what we're going to do now is talk about what does that look like graphically. Now, the first thing to realize is the position of the car that we're defining as x, that is the dependent variable here. That's what's changing with the independent variable, which is going to be time in this example. So this is where people get tripped up a little bit here. 99% of every graph they see in their life has y on this axis and x on this axis. Or now they're seeing x or any other variable that represents position. It doesn't have to be an x. I could call it d for distance or z or anything I want. But in any case, people usually are not really used to seeing time on the horizontal axis. That tends to throw people for a loop. Well, anyway, if I start my clock, if you will, here when the car is 10 meters away and moving at 2 meters per second, then the first point on my graph would be here, 0, 10. And then a second later, now the car's moving 2 meters per second, so this car will have moved to the right 2 meters. So now it's going to be 12 meters away. It's going to be roughly there. And then another second goes by, and now it's 14 meters away. And another second goes by, and now it's 16 meters away. And I'm just going to kind of extend this, and I'm going to do this in green. So if we were to plot position versus time for the green car, it might look something like this. Now, this line, one of the very important properties of a line is called slope. If I pick 2 points on the line, any 2 points at all, and we look at the rise and run, because slope, right, is rise over run. Now, normally, like in a coordinate system like this, that would be a change in y over change in x. But in this coordinate system, the run, that's this horizontal distance, is a change in time, and the rise is a change in x. So now the slope, right, is a change in x over a change in t. And that's going to be a number that's going to have units of meter per second. In fact, that's what this is right here. In fact, if I went through, like, remember, this point, this one right here, right there, was 12 meters in 1 second. Right? And when we go from here to here, it's up 2 meters over 1. And this is going to be true no matter what, up 2 over 1, up 2 over 1, up 2 more over 1. So the slope of this line is 2 meters per second. Now, it seems like there's only one piece of information there, but there's really 2 pieces. Right? It's positive 2 meters per second. The plus sign is giving the direction of the car. So there's really two pieces of information. There's the direction. This is positive, meaning in the plus x direction, meaning the car is moving to the right, and it's moving at 2 meters per second. If you put these together, you get what's called the velocity or average velocity of the car. I like to define velocity like this. Velocity is defined as rate that position changes. In this example, your velocity is describing how fast x is changing. And it's a vector quantity because it has a magnitude and a direction. Let me give you an example of one with a direction here. So we're going to talk about the red car for a moment. So imagine now, here's the x coordinate of the red car. Now it looks like at t equals 0, just roughly speaking, it looks like maybe it's starting 20 meters away. So the first point on that graph might look something like this. And again, for the sake of example, we're going to imagine that car is moving at 2 meters per second. Right, so after 1 second, hopefully we got an idea of that, that'll be at 18 meters now. 2 seconds, we're at 14 meters, and so forth. And now I can draw a graph that looks something like this for the red car. Now you'll notice these graphs intersect. Well, this intersection point right here is when these two cars pass one another. Not important for the discussion. What I want to point out about the red car is no matter what 2 points you pick on this graph, your change in x is a negative number, right? Because you're going down and over every time. So when you calculate the slope of the red car, which is the velocity of the red car, you're going to get a negative number. You're going to get minus 2 meters per second. So again, there's two pieces of information here. The red car is going 2 meters per second, and the velocity is negative with respect to this coordinate, which means to the left in my example. So velocity differs from speed in that it's got a direction attached to it. So that's what velocity is, rate that position changes. It's a vector quantity, so it has a magnitude and a direction. Usually what we do is we use plus and minus signs to keep track of the direction with respect to some coordinate system that the person puts into the problem. So that's probably enough for now. This is just meant to be an introductory video about velocity. I hope that this helps. Have a great day.